Hello students, in this section, we will learn about the sponge city construction, aspects of urban water systems and water management. The sponge city construction of the water management system includes the urban drainage system and river lake water body system. The urban drainage system comprises the urban rainwater pipe network and the excess rainwater runoff discharge system. The design of the urban rainwater pipe network and excess rainwater runoff discharge system should adhere to the principles of safety first, suitability to local conditions, cost-effectiveness, and practicality. These systems should ensure urban drainage and flood control safety while fulfilling the city as basic functions. Newly developed areas should adopt a separate drainage system, while redeveloped areas should implement combined drainage modifications alongside land block redevelopment and drainage system upgrades. Sewage must not be discharged into water bodies via the rainwater pipe system. During non-rainfall periods, sewage overflow into water bodies must be prevented in combined sewer systems. Urban rainwater pipelines should comply with the Outdoor Drainage Design Code GB 50014, and their size should be calculated based on the specified storm recurrence period. The minimum starting flow section for municipal pipelines should generally be no less than the N1000. In cases of complete regional reconstruction, the post-redevelopment runoff volume should not exceed the original runoff volume for the same design recurrence period. The sponge city construction of rivers and lakes should follow the principles of functional safety, ecological priority, comprehensive planning, local suitability, and integrated management. It should emphasize urban runoff pollution control and the improvement of water quality and ecological functions, and comply with the following provisions. The construction area includes the land control line on both sides of the water body, covering the blue line and the green belt. The targets for construction and management include urban runoff pollution discharged into water bodies, river lake habitats, and riparian green belts. Urban runoff pollution should pass through terrestrial buffer zones before entering water bodies. If the pollution is severe, it should be infiltrated or purified before discharge into the water body. Riparian green belts should be designed as terrestrial buffer zones with ecological services such as buffering, interception, adsorption, and soil water conservation. Rivers and lakes should enhance water connectivity and flow, coupled with ecological management to restore a healthy aquatic ecosystem, strengthen water purification functions, and improve water quality based on the characteristics of pollutants entering rivers and the water monitoring requirements. Monitoring and control facilities can be installed at discharge outlets and within water bodies. Here is the design process for the sponge city construction of urban drainage systems, which can be divided into 6 steps. Comprehensive analysis: collect and analyze the planning and current conditions of urban roads, surface elevation, rainwater pipe networks, and river systems in the construction area, and diagnose drainage problems. Index calculation: determine the specific goals and indicators for drainage system construction based on planning. Clarifying project tasks, technical selection and scale determination based on the drainage model and river network layout in the planning area. A spatial layout of the drainage system should be created. Key analysis should include the relationships between low-impact development facilities, drainage pipes, excess rainwater runoff discharge facilities, and receiving water bodies. The overall layout of facilities should be determined, with a focus on drainage capacity, storage volume for system upgrades, and the storage scale for managing excess rainwater. Rainwater storage facilities should address both peak flow reduction and runoff pollution control. Scheme design: conduct the design of drainage pipes, rainwater storage, non-point source pollution control, and excess rainwater runoff discharge. Multiple design options should be compared and the technical measures and scales should be determined through techno-economic analysis, review and optimization. Review the relevant indicators based on design goals. If they do not meet the requirements, optimization adjustments should be made. Design implementation. Prepare construction organization designs, environmental impact assessments, soil and water conservation plans. Project management. Labor safety and energy saving designs, and evaluate project costs and economic technical feasibility. Here is the design process for sponge city construction of rivers and lakes, which can also be divided into 6 steps. Comprehensive analysis. Investigate the current state of the river as functional positioning, hydrological regime, flood control, pollution sources, water quality, aquatic ecology, substrate, terrestrial plant communities, underlying surface, connectivity, location of hydraulic structures, and water intake discharge scheduling. Diagnose the problems in the river system. Index calculation. According to Shanghai Sponge City Construction Index, system-specific goals and indicators for river and lake management should be established based on planning, clarifying project construction tasks, technical selection and scale determination. Focus on analyzing the vertical relationships between rivers and surrounding greening, roads, squares, and buildings, and combine this with the distribution of non-point pollution sources and drainage pipes entering the river. Determine the overall project layout and construction scale around the design goals, with an emphasis on verifying storage capacity, pollutant reduction in the river, and the total length of ecological shoreline construction. Scheme design. Conduct designs for non-point source pollution control, interception, dredging, ecological riverbank protection, aquatic ecosystem restoration, terrestrial buffer zones, and water quality purification. Multiple design options should be evaluated, selecting advanced and economically viable technical measures to finalize the design scheme. Review and optimization. Review relevant indicators against design objectives. If they do not meet requirements, optimizations should be made. Design implementation. Prepare construction organization plans, environmental impact assessments, soil and water conservation measures, project management, labor safety and energy saving designs, as well as evaluations of project costs and economic technical feasibility. The urban rainwater drainage system and the excess rainwater runoff discharge system should be based on the urban overall planning. Relevant planning and construction conditions in the sponge city. Reduction of source rainwater runoff. Propose a layout and scale requirements for sponge facilities with storage and interception of runoff pollution functions. These facilities should be uniformly arranged and constructed in phases. It is also necessary to reasonably determine the vertical elevation relationships among the urban rainwater drainage pipes, the excess rainwater runoff discharge facilities, and the receiving water bodies, and coordinate these with the elevations of sponge city construction facilities in buildings, communities, green spaces, and road systems. The drainage distance of rainwater pipes should not exceed 600 meters. The plan layout of the urban self-drainage mode drainage system should meet the following regulations. The layout of rainwater pipes should organically connect with the size of blocks, distribution of waterways, and the arrangement of sponge facilities, aiming for a dispersed, multi-point, nearby, and self-draining layout. The determination of the service area should comply with the following regulations. When there are no waterways crossing the block, all blocks should be included in the municipal pipe service area, and rainwater should be collected and then discharged into the river. When there are waterways crossing a block, the service area of the municipal pipeline generally includes the road itself and 50 to 100 meters on each side, while the remaining area should be included in the community rainwater drainage service area, allowing for nearby outflow, the self-drainage pipe service area, and the drainage direction. of the land are as shown in the figure. Rainwater storage and regulation projects can be classified into source storage projects, pipe drainage storage projects, and excess rainwater storage projects. The location of these storage projects should be determined based on the purpose of regulation, drainage systems, pipe layouts, overflow pipe downstream water levels, and the surrounding environments. Various engineering methods can be combined to achieve storage goals. And in favorable conditions, mathematical models should be used for scheme optimization. The location of the storage pool should be determined according to the purpose of regulation and should comply with the following regulations. Storage pools for reducing peak flow and comprehensive rainwater utilization should be located at the source, and those in the rainwater utilization system should be designed as closed systems. Storage pools for reducing peak flow and controlling runoff pollution should be set in the pipe system and designed to be underground. Rainwater storage projects aimed at reducing peak flow should prioritize using existing storage spaces or facilities, ensuring that rainwater runoff within the service area is directed to these storage spaces, and that it is discharged in an orderly manner after rainfall ceases. The plan layout of river and lake water bodies should comply with the following regulations. The construction objectives should clarify the scale and distribution of the targets for treatment, select appropriate treatment technologies, and determine the types and scales of treatment facilities. The layout should be tailored to the site's current conditions. When arranging sponge facilities in terrestrial buffer zones, the layout requirements of functional facilities such as flood prevention channels, pedestrian paths, promenades, recreational squares, and waterfront platforms must be considered to ensure smooth water flow within the area. Sponge facilities for storage and purification should be primarily located in areas with severe runoff pollution and near the drainage networks discharging into rivers. The meandering characteristics of the river should be taken into account, and in accordance with relevant planning, the existing river trends should be retained and restored to preserve the natural curvature of the river while controlling the straightening of bends. The layout of in situ purification facilities should be based on the demand for pollutant reduction in water bodies, combined with landscape construction requirements, focusing on areas of the river with serious water quality pollution. The arrangement of low-impact development facilities, ecological management measures, and in situ purification facilities must ensure that the basic functions of flood drainage, water transport, and navigation in rivers and lakes are not adversely affected. The vertical design of river and lake water bodies should comply with the following regulations. The topographical features of the river construction area and the surrounding plots should be analyzed, allowing rainwater to flow freely in and out of low-impact development facilities and terrestrial buffer zones. Initial rain runoff or overflow wastewater stored in the storage pool can be elevated for purification before reuse or discharge. Water bodies should be designed based on the planning cross-section, combined with the requirements for aquatic plant and animal habitats. Vertical section designs can include rectangular, trapezoidal, and composite cross-sectional forms, and should feature various slopes, platform heights, widths, artificial islands, and deep and shallow riverbeds to create diverse cross-sectional forms. Through plant arrangements, a complete or semi-series riverside plant belt should be formed, consisting of submerged, floating leaf, emergent, and terrestrial plants from the water body to the land.